All right, today we're diving into a full-on cosmic ghost story. Seriously, it's a scientific detective case, and it's got everything. A giant family of stars, a mysterious ghost floating among them, and a discovery so incredibly rare it's rewriting what we thought we knew about how stars live and die. So, let's get into it.
Just take a look at this. It's amazing, right? What you're seeing here is this faint, beautiful cloud of gas. And yeah, it's pretty much the ghost of a star that died a long, long time ago. But here's the kicker. This thing isn't just drifting out in the middle of nowhere. Nope, it was found hanging out inside a super crowded star cluster. So the big mystery for scientists was, is this ghost actually part of the family? Or is it just a stranger passing by, a cosmic photobomber?
Okay, so to get to the bottom of this, we've got to meet the key players. Let's set the scene for this cosmic crime.
So here's our location, Messier 37. You can think of it as this big, bustling city of stars. It's one of the richest and brightest star clusters we can see. We're talking more than 4,000 stars, all born together about 500 million years ago. And it's right in the middle of this stellar city that our ghost was first seen.
So what even is an open cluster? Well, the easiest way to think about it is like a big family of stars. I mean, they were all born from the exact same giant cloud of gas and dust. That means they all have the same age and the same basic chemical recipe. And that's what makes them so cool for scientists. It's like having thousands of siblings all lined up, which makes it a perfect lab for studying how stars grow up and evolve.
And this is our ghost. It's called a planetary nebula. Now, that name is super misleading, okay? It has absolutely nothing to do with planets. Really, it's the beautiful, glowing shell of gas that a star, kind of like our sun, puffs out when it's in its final death throes. And right in the middle of that ghostly cloud is what's left behind. The star's tiny, crushed core, a white dwarf. This whole light show, it's just a fleeting moment in the grand scheme of a star's life.
So, this all brings us back to the big, central question, right? Just because this nebula looks like it's in the cluster doesn't mean it actually is. I mean, it could be thousands of light years closer to us or farther away. It could just be a coincidence, a simple trick of perspective. And that's why proving they're actually together, well, that would be a really, really big deal.
So how do you prove a ghost is related to a whole family of stars? Well, you need cold, hard evidence. Let's get into the cosmic forensics that blew this case wide open.
Okay, here's the absolute key. If that nebula's central star is a real member of the M37 family, then it has to be moving through space with all its brothers and sisters. They've got to be cruising through the galaxy in the same direction at the same speed. If not, then the whole thing is just a fluke.
And boom, here it is, the smoking gun. Astronomers looked at two critical things. First, their radial velocity. That's just how fast they're moving towards us or away from us. And second, their proper motion. That's how they're moving side to side across the sky. And just look at these numbers. They are practically identical. The central star and the cluster are moving in perfect lockstep. It is, without a doubt, the cosmic version of a DNA match. Case closed. The ghost is family.
Now, to really get how big of a deal this is, think about this for a second. In our entire Milky Way galaxy, with its hundreds of billions of stars, this is only the third time anyone has ever confirmed a planetary nebula is actually inside an open cluster. The third time! Finding one of these is like trying to find one specific, marked grain of sand on every beach on Earth combined. It's that rare, and that rarity is exactly what makes it so incredibly important.
Okay, so it's rare. We get it, but what does that mean? What secrets can this thing actually help us figure out? Well, it turns out this little ghost and its star are basically a Rosetta Stone for understanding how stars live and die.
It all boils down to this thing called the initial to final mass relation. The best way to picture it is like a cosmic recipe book. It's supposed to tell us if you start with a star of a certain mass, its initial mass, what mass will the little white dwarf it leaves behind have, its final mass. This recipe is like fundamental to understanding stars, but the problem is we have very few solid data points. It's been really, really hard to nail down.
And this is where our ghost becomes the hero. Here's how it works. Step 1. We know how old the cluster is, right? From that, we can figure out that the star that created this nebula must have started its life at about 2.8 times the mass of our Sun. That's its initial mass. Step 2. We can actually measure the white dwarf it left behind and find its final mass. And just like that, we have a perfect golden data point, a direct link between a star's birth weight and its corpse's weight. And that one data point helps us refine that cosmic recipe for every other star out there.
But wait, just when you think the case is solved and everything makes sense, the story takes another sharp turn. Because the star at the center of all this, the ghost's heart, is just, well, it's really weird.
Take a look. See that tiny blue dot right in the middle? That's it. That's what's left of a star that used to be way bigger than our sun. And the more scientists looked at it, the stranger it got.
Yeah, this is no ordinary white dwarf. First off, it's way heavier than usual. We're talking 85% of the sun's mass all crammed into something the size of Earth. It's also this super rare type of star called a PG 1159 star. What that means is its outer layers got totally stripped away, leaving this weird atmosphere of just helium and carbon. It's like the star got turned inside out. And if that wasn't enough, it might be magnetic. And we know for a fact that it's spinning around every 10.5 hours or so. Every one of these details just makes the mystery even deeper.
So it turns out solving one cosmic mystery has just opened the door to an even bigger one. And this final twist, man, it calls into question the very tools we use to tell time on a cosmic scale.
So here's the puzzle. There are basically two different clocks you can use to figure out when this star died. Clock number 1. You measure how fast the gas in the nebula is expanding. That tells you the crime happened about 78,000 years ago. Okay, but clock number 2. You measure how much the white dwarf at the center has cooled down. And that clock says the star died around 350,000 years ago. Those two numbers should be the same, but they're not even close. They're wildly different.
Now, this isn't some calculation error. It's actually a massive clue. When you see a gap that big, it tells you that your models, your understanding of how dead stars cool off or how these nebulae actually expand, are missing something huge. This one object is literally forcing scientists to go back and rewrite the rulebook.
So think about it. This one little ghost, found in a city of stars, has given us so much. We got a confirmed family member, a golden ticket data point for stellar evolution, a totally bizarre new kind of star to puzzle over, and a fundamental mystery about how cosmic clocks even work. It really makes you wonder, doesn't it? What other huge secrets are just hiding out there in these star clusters, waiting in plain sight for someone to come along and find them?